Hello, guys. We are back into the animation workshop, and I'm recording again because it didn't record in the meeting fortunately. So I'm gonna record all of again and made some changes also in the slide for overlapping action, the animation principles. But yeah, I think it will be faster here. So let's just start. So last time we talked about animation principles in the workshop one about posing, staging, and appeal, and then anticipation, exaggeration, slow in and slow out, timing, and blockout. So we learn what they do, how they look like when we implement these animations in the animations, each in the assets, in characters, how they look like. In the workshop now, we will talk about these animations. They are the animation fundamentals. They are arcs, squash and stretch, follow through, and overlapping action. Okay, so let's start talking about squash and stretch. What does it mean? What is squash and stretch? This principle is like a complement to the other animation principles, like anticipation, exaggeration, timings, posing. We use this to accentuate these actions and to create like an organical aspect for a character. So it's pretty cool when we use it correctly, and it gives like amazing aspects to your animations. And how we do that? Usually in 3D softwares, we use like through the rigs. It's pretty easy to do that when you set up your rig correctly, and you can create these amazing effects like really a clay. Um, in drawings, you can just do directly in the paper this effect. In 3D, you have to use rig, but what about voxels? How we can give this effect with voxels? So we know our mesh is not deformable. It's always the same, like a square will be always a square. You can deform it. So how we can give smooth squash and stretch movements? There are some examples. So you can see the slime humanoid here, and it's like you know it's like made of slime because of how it behaves, how the movement is all like slippery, and you know also the limbs they have like this kind of overlapping actions happening, and this gives this sensation. So what we are doing here is just using the nodes. It's not models. The models you see, they are all solid, but the nodes, they go through each other and creating this amazing effect of squash and stretch feeling. But there are also other ways to do that. With voxels, you can split your model into many pieces. In this case, like, I don't know, I think 34 pieces just for this monster, and it's a lot of work. Um, I don't recommend doing that at all. Like, in most of the cases, you can find better ways to do it without like splitting every piece of the character. But yeah, in fact, you have to anticipate your rig, like thinking the animation you want to do in the future. So you have to anticipate your rig and split the model into many part, many parts. in order to create some animation like this. So because if you want to create an animation like this, you have to have this in mind and anticipate that in rig before doing animation. Well, again, it's like you don't have to exaggerate like this. You don't have to split your assets like this. Like it's not the ideal. You can have issues with the fighting. You can have issues with processing, like the matching. The game will doesn't do not support too much nodes and can have like a backlash effect in the game. So doesn't need to do that, okay, that much. But you can find better ways how to do that and still looks pretty good. So here's the first example with anticipation, exaggeration, okay? And here is the example how it looks like when we add anticipation, exaggeration, plus scratch and stretch. I don't know if you can see how scratch and stretch looks like here, but I think it's pretty visible. Everything is like scratching and stretching. Even if it's only in the vertical, it's still amazing how we can create pretty good effects with that. And here you can see how we made that. Just three pieces. And using these three pieces, you can create amazing effects. Be careful with the fighting when splitting the model because this technique, this technique, uh, to do this technique, you need to be sure that the colors are the same in the place you are applying and has to be strategically placed. So be careful with the fighting. Like here, the cyan and the blue here, they are like overlapping each other surfaces, but as the color is the same, it's okay. In the green area here, um, doesn't have any issues with the fighting because it's there's no other surface that the surface are fighting for. So it's pretty cool. And here another example in anticipation and exaggeration only. And here anticipation and exaggeration and squash and stretch. You can see in slow motion the chest bending. You can see like squashing like this and then stretching pretty in just few moments, in just few frames, but it's still enough to smooth your animation even more. So it's pretty cool effect. And the only thing I did, I just split the model into two. So you can see the two models splitting and then I can animate them separately. And how you give the same effect in characters. So to give the same effect in characters, you have to just animate the nodes. You want to be able to split the models, like, but you already have a lot of nodes that you can use it to give this effect. So here we have an example of the guy free falling and then smashing on the ground. And then we have examples here like scratching, stretching, scratching again, and stretching again. So it's pretty much as a ball behaves. You can see the similarities between the ball here squashing stretching and the human squashing stretching on the ground. Uh, it's pretty much the same. With the difference, it's like a human, it's not like a ball, but the motions, the arcs of the body, they are doing pretty much the same thing. So now, what is an arcs? In animations, arcs refers to the natural path that an object or body part follows when moving. Um, the principle of arcs is based on the idea that most natural movements follow a curved trajectory trajectory rather than straight line. So it means that you usually you see in all the humans or actually life form, the movements are usually arcs and not like straight lines. If you do like straight lines, you'll be a robot. Even though like robots have arcs movements, but most of the cases like matchings they have linear movements, but then um, there's exceptions, okay, guys, but it's more common to see linear movement in matchings than humans. If humans are doing straight lines, they are like not doing that intentionally or is not natural. Here an example how an animation has a lot of arcs. You can see the bounces happening. You can see the arcs, the hips following all of the arcs and how natural it looks like. Most of the cases for characters, straight lines are bad. You need to think in arcs for every motion in the body. So if I'm sure if you could see like linear instead of arcs here, it will be broken. This animation will be broken. It will be messed up with everything. So you see in every motion, like this is we are tracking the hands, here we are tracking the leg, and we see the arcs everywhere. And that's really important um, thing to keep in mind when animating. Another example, and yes, arcs reduce noise in the movements. If you have too much, like the hands doing like this, like you're gonna do this movement, but then you do like this. It's not natural to do that. Like this shaking effect is not natural. So if you want just to bend your arm, you're not gonna do this. You just do this, and the arc movement will you do, you know. So there are many animations I see we have issues like noises happening. So when we eliminate these noises, it does the arc movements, and that's what we are looking for. So here you can notice that the movements without arcs are lifeless and movements with arcs feel more organic and natural. Here again, guys, I use linear movements. You can see they are just straight lines. Even if the change is lively, the arcs are pretty slight. You can see the difference between the movements. You can see here is like sharp and here is like polished. It's like just a small difference because here you don't have like really big arcs, but you see in another example um, how what's the difference they do. And here I'm teaching like in this video showing how to do a simple jump, a simple arc, just from one jumping from point A to B with three keyframes. Okay, a keyframe for the beginning, the end, and another key for the jump, which this one I'm doing. And then I teach like using the right curves. You have the arc that you want. So using easy out for the y-axis and easy in when you are like for the I can't draw in the screen, but when you are in the air, you're rising. We use it right ease out, okay? So for this movement, we do ease out. If it's linear, the monster will go like in linear motion and it's totally broken. But if you use ease out, it will do this arc, okay? You're jumping and you want to do the arc movement, so you have to go to ease out. And then from the top to the ground, you use ease in because you start slow and then following with falling faster. Okay. Uh, and then here we have a perfect example. What I meant with linear, the difference with easy out. It's the same motion, it's the same keyframes. The unique thing that changed is the keys, is the curves. You see, and the curves in y-axis, and you see the difference is absurd. The difference is absurd. So here is triangular the movements because linearity creates linear movements, and with easy we create arc movements. So your best friend to create arc movements is easy in, is out. Okay. Then let's talk about follow through and overlapping action. Um, it's basically the reaction of the body in parts, body parts or accessories like cape, hat, long hair, tail, jewelry, pendants, long ears, antennas, or any other flexible or loose accessories in general. Um, so yeah, it's like we are talking about physics here. For every action, there's an equal and opposite reaction. So we see here like the cape, and they are like behaving as should be, like they are following the physics, the real physics. I know we are talking about angel flying or something like that, uh, but it's we are doing art here, and in spite of everything we do, the animation is artistic. Physics are important to give credibility to your animations. So you are doing like an anvil flying, but if you still apply physics, it will give credibility to that. Oh, it's anvil flying. Oh, but nice physics. I think it's real. So that's how behaves your brain. Like you can trick your brain through that. Um, so basically, follow through is like the object following with delayed motion. So it's like this hand, I'm um I'm pulling this hand and moving, and this hand, this arm here is reacting with delay. So you can see all the delay happening. It's basically that it works in chain motion and delayed motion. And here is an example or good and old anvil falling. And what if we add a cape? What if we add a cape? How it will behave? So now the cape will behave like as a cape. It will continue the movement of the body, and like here is rising, you can see like the cape still continues the movement, and then when it starts falling, the cape shakes in the opposite directions, and then the anvil start falling, but the cape at a certain moment, the anvil is like 3 4 frames below, and then the cape is still there. The bottom, the last node of the cape, the last part of the cape, which has a lot of delay from the anvil, is still in the same position. So you can track here, the anvil will start falling, but the cape is still almost there in the same position. So this is a delayed motion from expected motion and delayed from follow through and overlapping action. And it's important that everything, like this cape, it could be a cape of leather or I don't know, any kind of cloth material. Like it could be light or heavy or from metal. And all of this is important. The material of the object is important to give you to take into consideration when you are animating something. So because the follow through and overlapping action will be different to each kind of material you're creating. Okay. So if it's a light material, it would take much more frames to react to the body. Imagine if it was made of um, metal, it would be heavy. But what if it was made of, I don't know, some really light material like, I don't know, paper. Okay, let's imagine paper. Uh, you know, your brain know the way it would behave should be different. So yeah, that's about follow through. Another thing is the coins in this scenario here is totally dependent on the chest movement because the chest moved, but everything it is inside is still continuing that movement. It means the coins will continue that movement. And because the coin is lighter than the chest, they probably gonna go higher from the movement that the chest did. The chest is heavier, but the coin is lighter, and it will probably push the the coin higher than it should. And then the coin will continue that movement and will keep falling. The chest is it already finished its motion, but the coin keeps doing the movement from the chest. That's basically follow through as well. So uh, it's always important to think about that. Secondary motions are dependent to the following object. So it's recommended to to animate it after the main movements are set. Okay, so here is a movement without follow through, and here with follow through. You can see the differences. You can see like this one, you don't see the antenna moving, but here you see the antenna moving. Although you see still in this one a small movement like a squash and stretch movement, a squashing movement when when the monster lands. This is kind of a follow through movement, okay, with squash principle. Um, Although this one you see it still reacts even more. So the follow through and overlapping action is still happening and it's affecting the antenna. So that's why it's important to first animate the jump, animate the body, and then animate the secondary motions like antenna, cape, tail, or any other accessory. Here is an example like, oh no, I forgot to delete here with follow through. With it's wrong without follow through. I know it's correct. It's correct. Sorry. Um, so this is wrong, totally wrong, because we are moving the arms, but the body is not reacting. So we know that everything, all the movements you do in your body, it will have some kind of reaction in other parts of your body. If their reaction has more height and speed, it will uh, impact totally the other parts of the body. If the part doesn't have much height and speed, it won't affect that at all. So here in this example is the correct way. So we have this motion that is leading the motion, and what is happening is that the hips is moving to the opposite direction because the human body is trying to rebalance to keep balance of it. So it goes to the opposite direction. If you try yourself to raise your hand really fast, you see that your body shakes and try to rebalance. Uh, so if you stand and try to do all of this, you see that some shaking will happen. Even if you have even more eight holding in your hand, you see this will intensify. Or if you do faster, it will intensify because with faster objects, creates adds more eight to the object. So um, it reacts to all of the parts of the body. So the hips is going to the opposite direction, and because of that, the torso is dependent on the hips, and because of that, it's also reacting to the opposite direction of the hips for a few frames. You can notice here, but it's here. So the torso did like this movement, and the chest is doing this movement for a few frames. So you have something like that happening here. Um, it's just few frames, but you feel it, and then the head is being reacted by the torso. So you have a totally chain reaction only from one action. I know it's overwhelming if you think about all of this when animating, but if you want realistic results, it's totally important to do that. So yeah, we talked about animation principles in these two workshops. I think it was pretty complete to work and polish your animations and create like really nice effects. Um, and I want to challenge you now as with an exercise, animation exercise. I'm gonna share with you this little monster, and your exercise will be to create an accessory or a trait to the voxel monster. Like it can be a hat or a tail or a mustache or anything you think is fun um, or interesting. And you're gonna practice follow through and overlapping action using these extra accessories. But also, you're gonna animate the monster doing a jump. It can be a jump forward, jump in the same place, a jump in a back flip or front flip, or a twist, or anything you want. Okay, just do a jump, jump, rise, fall, and that's what I want to see. I want to see your notion of anticipation in action, posing, timings, arcs, overlapping action, squash and stretch. Okay, you can also um, edit anything in the rig. You can edit the eyes of the monster, the body. You can split it into many models you want. Do it whatever you want. Okay, you can change the colors. You are free. I just want to see what you guys are gonna do, and I'm excited to see it. And yeah, here I talk about VoxView, and we are going to share with you guys VoxView. This amazing tool was made for animations first, but to visualize animations in Game Maker and Game Client because we have some several bugs visualizing uh, Voxelite, the animations in Voxelite, and then in GameMaker and Gameplanet, they usually seem different. And then this tool is to oscillate on that, not only on that, but all of the aspects in animation or even modeling. So I'm gonna share with you details in your Slack, and I think that's it, guys. So I see you during the reviews. Thanks a lot, and see you there. Bye bye.